It's been a pleasure to have you once again, where we are going to be looking at relative molecular mass. When we say relative molecular mass, what do we mean? It simply means the mass of one mole of a substance. The substance can either be a compound or a molecule. Oxygen atom has 16 grams as the mass of one atom of oxygen. But oxygen gas exists as a diatomic molecule. So if we have oxygen gas, the relative molecular mass of oxygen gas is simply 2 multiplied by the number 16, which gives us 32. So that is the relative molecular mass of oxygen gas. We can also have other diatomic gases like nitrogen. Nitrogen, which atomic mass number is 14. So the relative molecular mass is N2, which is 2 multiplied by 14 to give us 28. So that is how you calculate the relative molecular masses of molecules. Now let's take a look at relative molecular masses of compound. How do you obtain the relative molecular masses of compound? You simply obtain it by summing together the relative atomic masses of the component element that makes up the compound. When we say relative molecular mass, we are trying to relate it with the mass of 12 grams of carbon. Of course, carbon exists as an isotope with 3 different isotopes. The mass of, or the relative atomic mass of these 3 isotopes can be obtained by taking the average of these 3 isotopes. That gives us the relative atomic mass of carbon. So, in determining the masses of all other substances, we relate it with what? The mass of 12 grams of carbon isotopes. That gives us the relative molecular masses of substances. Let's take, for example, we have a simple substance like sodium chloride. Okay, of course, sodium chloride is made up of sodium and chlorine. So if we want to find the relative molecular mass of sodium chloride, what we simply do is to sum the mass of sodium and the mass of chlorine together. That gives us the relative molecular mass of sodium chloride. So sodium having a mass of 23, we sum it together with chlorine having a mass of 35.5. So the two of them added together will give us the relative molecular mass of sodium chloride. It is as simple as that. So now let's take a look at some worked examples on how to find the relative molecular mass of compound. Let's take a look at the first question here. Calculate the relative molecular masses of the following compounds. The first compound we have here is calcium chloride. So, to calculate the relative molecular mass of calcium chloride, what you simply do is you add the mass of calcium plus the mass of chlorine. Of course, the mass of chlorine is 35.5, but chlorine is having 2 atoms already multiplied by the chlorine. So you multiply 2 times 35.5 and add it to calcium. That gives you the relative molecular mass of calcium chloride. So now let's have it as calcium chloride. So the relative molecular mass of calcium chloride is simply 40 plus 2 times 35.5. So we can simply have 40 plus, of course, 2 times 35.5 will give us 71. So it will give us the number 111 as the relative molecular mass of calcium chloride. Of course, relative molecular mass has no unit because it has to do with the summation of the relative atomic masses of elements in the compound. Let's take a look at the second example here, which is sodium Tetra Oxosulfate 6. If you are asked to find the relative molecular mass of sodium Tetra Oxosulfate 6, what you simply do is sodium here has 2 atoms. So you multiply 2 by the mass of 1 atom of sodium. Then you add it to 1 multiplied by the mass of 1 atom of sulfur. And you add it to 4 multiplied by the mass of 1 atom of oxygen. So we can have something like Na2SO4 will give us 2 multiplied by 23, which is the mass of sodium, and 1 multiplied by 32 plus 4 multiplied by 16. Of course, this will give us 46 plus 32 plus 64. So summing this together will give us 142 as the relative molecular mass of sodium tetraoxosulfate 6. It is as simple as that. Now let's take a look at the third question here. Magnesium trioxocarbonate 4. So magnesium trioxocarbonate 4, we can calculate the relative molecular mass of magnesium trioxocarbonate 4 by simply adding the mass of magnesium, which is 24, plus mass of carbon, which is 12, plus 3 multiplied by 16. Of course, this will give us 24 plus 12 plus 48. So summing this together will give us 84. So this is the relative molecular mass of magnesium trioxocarbonate 4. With this, we'll come to the end of today's class. But join us in our next class, where we are going to be looking at more examples on how to calculate the relative molecular masses of substances. This serves as a basic in the study of chemistry. Your students find it very difficult to calculate the relative molecular masses of substances. If you cannot at this stage calculate the relative molecular masses of substances or compound, I don't know how it will look like when you are asked to do some simple calculations in chemistry, where this is simply where you're supposed to start from. So join us in that class, where we are going to look at more examples on relative molecular masses. So see you then in that class.